Okay, another day, another recording. So let's start again with a warm-up. Today we're going to be working with molarity, and so we got to figure out what molarity is. But I do want to touch a point of vocabulary. If you were a chemist and you had two solutions, one solution you got 100 grams of solvent with only 0.01 grams of solute dissolved, and another solution you got 100 grams of solvent with 25 grams of solute dissolved. So the question is, how would a chemist discuss these solutions without any other information? Well, what he would say is one solution is dilute and one solution is concentrated. Dilute simply means a very small amount of solute per the amount of solvent, like 0.01 grams and 100 grams of solvent. The other one is more concentrated. Simply means it's got more solute per the amount of solvent, which is clearly true for the 25 grams of solute divided in 100 grams of solvent. Okay, concentration again. Remember, it's a general term that is used to quantitatively express the amount of solute per amount of solvent or solution. Example we had yesterday's notes was mass percent, so you know this now. Today we're going to talk about molarity. So what is molarity? Okay, molarity is a measure of concentration, and we use the capital letter M to represent it in calculations. What does M and molarity stand for, though? What does it really mean? The key formula is this: molarity equals, molarity is capital M, moles, which we abbreviate with the letter N, per liter of solution. So the molarity of a solution is the number of moles of solute per liter of solution. It has the units moles per liter. Now, why do we use capital M and lowercase n, capital M for molarity and lowercase n for moles? I don't know. Someone invented it years ago and decided to use those letters, and they became kind of standard in chemistry. So, for instance, a 5 molar solution then has 5 moles per liter, and we would write it as 5M, capital M. So here's a simple problem. How many moles of sucrose are in 0.5 liters of a 0.5 molar solution? So another way of saying this, that it's moles per liter, is say molar solution. So it's 0.5 moles per liter of solution. So there's our formula. Molarity, which in this case is 0.5, equals moles divided by volume in liters, and we're told that it's 0.5 liters. So we solve for N. So N has to equal molarity times liters. Remember, molarity has the units, moles per liter. So moles per liter times liters gives us moles. So 0.5 liters times 0.5 moles per liter of sucrose gives us 0.25 moles of sucrose. So that's how we do it. Pretty simple. Now, this one's a little bit harder, but not much. What is the molarity of a solution if 5 grams of sodium chloride is dissolved in a final volume of a half liter of water? Well, grams is not moles, but we know how to convert from grams to moles as long as we've got the amount that we start with in grams, and we've got a formula so we can find the molar mass. So we're still going to use molarity equals moles per liter. This time we don't need to rearrange it, but we have to calculate moles before we can do the problem. How do we find moles? We divide grams by molar mass. So we've got to figure out the molar mass of sodium chloride. So sodium is 22.99 grams per mole, chlorine 35.45 grams per mole. Add them together, it's 58.44 grams per mole, and then we just take our 5 grams and divide it by 58.44 grams per mole. Everything drops out except moles. So that's how many moles of sodium chloride are in the solution. Remember, we have a volume already, and that volume is a half liter. So we take our moles, divide it by liters so that we've got moles per liter, and we come up with 0.171 molar sodium chloride solution.